So what we have done, we have divided our RAM into three equal sized frames, and we have here our page string in secondary memory. Now we will try to implement the page replacement algorithm using FIFO. So what happens here? First, now the CPU is going to ask for this page with index 4. So CPU will at the beginning look for this page into the RAM, and as all the frames are empty or the RAM is empty, as per the definition of page fault, it essentially occurs here. When a page referenced by CPU is not found in the main memory, it is called as a page fault. CPU is asking for a page with index 4 into the RAM and it is not into the main memory, so a page fault occurs here. Let me assume one variable here, number of page faults, under which we will compute the number of page faults which will occur in the entire process. So now this page with index 4 is pushed into the first empty frame into your RAM. Once this is done, next CPU will move for the rest items one by one. That means CPU next will ask for the page with index 7. Again, this page with index 7 is not available into the RAM, so one page fault occurs here. So increment the number of page faults by 1. So up to this point of time, the total number of page faults is 7. And insert the page into the next empty frame. After processing this page with index 7, CPU will now ask for the page with index 6. Again, a page fault occurs here, so you have to increment the number of page faults by 1 and then push the page with index 6 into the next empty frame into the RAM, which is F2. Now, once you have pushed this page with index 6 into the RAM, you can notice that your RAM is now full. So, when CPU will ask for the next page, which has index 1, essentially again page fault occurs as per the definition, and we have another added problem here. And what is the problem? You can see that the RAM is full. There is no more room available here. So to insert this page with index 1, you need to replace an existing item from the RAM. So at first, increment the number of page faults by 1. So the total number of page faults until now has become 4. And as the algorithm is FIFO, try to figure out among these pages, page with index 4, page with index 7 and 6, which one is the first to arrive into the RAM. If you can remember, page with index 4 was the first page to arrive into the RAM. So if you follow FIFO algorithm, you need to replace this 4 with page with index 1. Now move on to the next string, which has page index 7. Now essentially we will have no page fault here. Why? Because the page with index 7 is already there into frame 1 of the RAM. So we don't need to increment the number of page faults here in this case. Next, let me go on to the next page, which has index 6, which is again available into the RAM. So you don't need to increment the number of page faults once again. No page fault is here. Next, come to page with index 1. Again, it is available into the RAM. CPU can directly get it from the RAM. So there is no chance of page fault, no increment in number of page faults variable. Then move to the next page, which has index 2. Now when CPU will look for this page with index 2 into the RAM, essentially it is not available into the RAM. So here we have a page fault. You need to increment the number of page faults by 1. So after this point of time, the number of page faults has become 5. Again, follow the FIFO algorithm among pages with indices 1, 7 and 6. Now 7 is the first page which has arrived into the RAM among these 3. You need to replace this page 7 with the page 2. So replace it. Next, let me move on to the next page. Next page has an index of 7. When CPU will look for this page into the RAM, it is not available into your RAM, so page fault occurs. Increment the number of page faults by 1. So the number of page faults has now become 6, and replace the first arrived item into the RAM, which is now 6, with the new page which has index 7. Next, move on to the next page. It has index 2. If you look into the RAM, CPU will find it there. So there is no page fault. For the last page into your page string into secondary memory, you don't need to increment the number of page faults. So now the loading of all the pages has been done. Let me add the total number of page faults which have occurred when the page replacement algorithm is FIFO. It is 6. Now let me move to the next part of the problem. Next part of the problem asks you to calculate the hit ratio and miss ratio. So from our discussion, we can conclude that total number of page faults which has occurred when our replacement method was FIFO is 6. So total number of page hits is equals to total number of references minus total number of page misses or page faults. Total number of references is 10 and total number of page faults is 6. So 4 times we had a hit when the page replacement algorithm was FIFO. So your hit ratio essentially becomes 4/10 or 40%. So miss ratio is 1 minus hit ratio or 60%. So this was your hit ratio and miss ratio calculation when your page replacement algorithm was FIFO.